Welcome to Production Resources Incorporated Learning Center video series. In this video, we will be programming a red sensor. A red sensor is a static sensor event type that is normally closed to ground. When a static event type changes state, a fault will be generated. For a red sensor, if it opens, that's when the fault will be generated. All static events are typically monitored for the entire stroke, 360 degrees. An example of a red sensor application would be monitoring the end of stock. The sensor is monitoring that material is present. When material is no longer present, the red sensor goes from closed to open and a fault is generated. To program a red sensor, make sure that the program run key is in the program position so that the main menu is displayed. Select Tool Manager on the soft key of the main screen. In our example, we will be adding a red sensor to an existing tool number. The programming of the sensor is the same if you were creating a new tool number. Select the tool number from the list of programs that you want to edit. The tool number we are editing for our red sensor is 4656A. We'll select that so that it is highlighted in green. We'll then press the edit key located on the right-hand side of the screen. You'll notice that SmartPAC Pro is a menu-driven program that will guide you through the programming process page by page. We will now select Die Protection Key, and a list of available inputs will appear on the screen. In our application, the red sensor is physically connected to sensor input number 2. We'll choose sensor 2 to program the red sensor. A list of sensor names will be displayed after selecting sensor 2. If the sensor application you are monitoring is not listed in the canned list of names, you can create a custom name by selecting the New Entry button located on the right side of the screen. In our example, we will name this red sensor End of Stock. The End of Stock sensor is normally closed. The sensor is continuously monitoring the presence of material. When the material is no longer seen by the sensor, it will change state from closed to open and generate an end of stock fault. As we mentioned, we'll select red as our sensor type. We now determine how we want the press to stop when an end of stock fault is detected. Under emergency stop, an e-stop will be generated once the sensor fault is detected. As we discussed earlier, static events, both reds and yellow sensors, are constantly monitored so that the e-stop command can be generated anywhere during the press cycle. Emergency stop is typically selected when the sensor fault being monitored could cause die damage when a fault is detected. When selecting top stop, the press will stop at the top of the stroke after the fault is detected. For this application, we will create a top stop when the end of stock sensor fault is generated. We chose top stop since end of material is not an event that could typically cause a die crash when the fault occurs. We'll simply stop on the top of the stroke and prepare to change the coil. The third stop type, known as Smart Stop, is a combination of emergency stop and top stop. Which stop type generated is determined by the program's critical angle. Critical angle is the latest degree angle in the stroke when an emergency stop command can be generated, and the RAM will stop prior to punch engagement. In our application, for this tool, we have determined that critical angle is 100 degrees. If a sensor fault is generated anywhere between 185 degrees and 100 degrees, an emergency stop command will be generated. If the sensor faults between 100 degrees and 185 degrees, a top stop command will be generated. Please refer to Production Resources Incorporated Learning Center for more information on determining the critical angle and using Smart Stop. As we mentioned, in this application, we'll be choosing top stop. In most instances, the programming of the red sensor is now complete. SmartPAC does offer additional features that may be used for certain red sensor applications. By definition, red sensors are static events that are monitored for the entire press cycle and will generate a fault anytime the sensor changes state. There may be instances where conditions outside of our control cause the red sensor to change state and may create what are known as nuisance faults. Nuisance faults are changes in state of the sensor that do not have to do with the event that we're actually monitoring. A bypass angle can be used to ignore the status of the sensor during the programmed angle. If you notice that the sensor has a tendency to open and close at a certain portion of the stroke, and this status change is not an actual fault, programming a bypass angle can help eliminate these nuisance faults. In our example, we have programmed a sensor bypass angle from 165 degrees to 185 degrees. Sensor actuations during the bypass angle will be ignored. As you see, the sensor actuations during the portion of the stroke that is highlighted in red will continue to generate faults. The gray area is where we choose to ignore the sensor faults. The minimum actuation time is the time in milliseconds that a red sensor can change state from closed to open, and SmartPAC will ignore that change. If we set a minimum actuation time to 10 milliseconds, SmartPAC will ignore any sensor actuations that are less than 10 milliseconds. Any actuation changes longer than 10 milliseconds will generate a sensor fault. This basically is typically created by vibration or what's known as mechanical sensor bounce. The sensor goes from on to off very quickly, but it is not an indication of an actual fault. In the auto reset, when auto reset is turned on and fault not required, the red sensor fault will automatically be cleared on the SmartPAC if the red sensor output reverts back to the normally closed state. If auto reset is turned off, a manual reset on the SmartPAC is required to reset all red sensor faults. Auto reset off is the default setting. We can also do an auto reset on, fault required. When selected, the red sensor must change state, meaning it must cycle from closed to open and then back to closed. This status must occur during the active angle that we program for that sensor. In this example, the sensor must go from closed to open and then back to closed during our fault required time as shown in the green square. That completes our programming of a red sensor. I'd like to thank you for your time, and we encourage you to visit the Production Resources Incorporated Learning Center for additional training videos and application knowledge. Thank you.